This is my huge data center server rack, and once upon a time, this was the UPS that ran everything in it, but obviously that's quite inadequate. And here's my OG server rack with my Dream Machine SE and a switch and other things, and that used to be backed up by this UPS. It's heavy, but that doesn't work anymore either. So in this video, we got two new ones. Yes, I have got two brand new UPS devices, one for here and this one for down the house. But before we get into all of that and what they do and why and how, etc., bit of a disclaimer. I'm not a UPS expert. This is the first time I've done any kind of research and any kind of, let's call it, dedicated effort to find the right UPS units. So that is what I know. And I'll convey what I've gone through and how I've done it, but I don't know most of the stats that these come with, all the different specs and features. I don't know what they mean. So if I don't, and if I get something wrong, I apologize, but put it down in the comments below and we can all learn from it. And these are not provided for review. These are not devices that CyberPower or anyone else has sent. I have bought these with money. So I'm really hoping that they will be great because I'm going to use these for a long time, or at least that's the plan. So I think first thing, before I start talking about what a UPS is and why you should use one, let's get these out of the boxes and actually just have a look at them before we get into all of the nitty-gritty. Let's start with the big one. This is the rack-mounted version of a UPS. Not entirely sure if there's a box in the box, but let's find out. All right, what do we got? Okay, so we got a whole bunch of cables. These are good. I'll explain more about what we need all these for. All right, cool. This, I assume, is going to be some of the rack mounted stuff. We'll get into that in just a second. Then we have some of the rack mount brackets, so we can actually put it on. Oh, they're solid. That's a lot of weight in it too, right? You can probably guess where it's going on the rack. At the bottom, right. And then we have a bunch of styrofoam. It's fine. Ow. Ta-da! That is incredibly heavy when you have nerd arms. But here it is, the CyberPower model OLS 2000 ERT2UA. Rolls right off the tongue. Anyway, we'll talk more about that a bit later. We got some bracketry. Let's just have a look what's here. Yeah, there's some, I don't think they slide, but there's some mounts to put it in the rack. All right, and then we have a whole bunch of cables. These are good. These are EC13 standard to EC14 standard, and we'll get to more about that as well and why we need more of these probably. All right, the other one's got to be lighter. Yeah, that's heavy. Just for comparison, here's what was on it before. Yeah, bit of a different beast. Anyway, let's get to, we'll just take the other one out here. Very nice. And, all right, we've got some more cables here. Very good. And one moment. Right, so here's the other one, which is the desk mount. It's also quite a lot bigger than the previous. This is not the one that was in the house, but it's similar. You can see there's quite a different beast. They're both CyberPower, but very different applications. which is why we're upgrading, right? So this is the OLS 1500E. Before we get to installing these two UPS devices, I want to just cover a few sort of things about what they are and why you should use them, right? So a UPS is an uninterruptible power supply. Now, it's very commonly used in a lot of installations because if the power goes, you're in trouble, right? So these are quite common in all sorts of different guises, and we'll get to that in just a minute. So a UPS sits in between your device, so that's usually like your computer or your equipment of some sort, and the power grid, right? So it's sort of a thing that makes sure that if the power goes out, which happens a lot here, these will kick in and power your devices, and you'll still have the devices don't just die, right? So that's great. Now you could say, well, my laptop already has a battery and maybe you use a mobile connection and you'd be fine, but a lot of devices, especially electronics, do not like being switched off and on like that. Now I had a power outage 2 weeks ago, I think it was, from today time of filming, about 2 weeks ago, where the power went off, on, off, on, off, on, in about 20 seconds, right? So, tick, 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 tick. And what happened is that that particular sequence of turning things on and off is actually a reset for a lot of devices. So not only did it screw up my network because the thing turned on and off all the time, and my UPS devices had died. Remember I told you that at the start? They actually didn't work, but I'll get to more why in just a second. But a lot of my IoT devices actually reset, or they restarted to a point of pairing, and it's a pain. Now, with the IoT devices, that's tricky to get them all on a UPS device, but definitely with my network equipment, it is crucial that you have something like a UPS that makes sure that these devices don't lose power. So anything with spinning disks, a NAS, an NVR, whatever that might be, anything that runs some sort of configuration like my Dream Machine, they do not like losing power just like that. They like being shut down and then turning off, right? So that's why we have UPS devices, and that's why you need one or two or many. It is really worth it. So how does it work? How do these things actually work? Now you get the concept. There's a battery inside. When the power goes, you use the battery. There's a little bit more to it than that, as I found out. So the two original UPSs that don't work, that I bought, kinda worked. And that was what lulled me into a false sense of security. Now they were what's called line interactive topology. I know. There's that, and then there's what's called sort of offline UPSs. The way they work is that the power goes through the UPS, bypasses the battery, and goes straight to your devices. So on the back here, there's some power points, and those are powered all the time from the grid. So power goes in, power comes out. So when there is a power outage, there's a very slight delay of when it's switched to battery. So we're talking 4 milliseconds, 10 milliseconds, something like that, but there is a delay until the power runs on the battery. Now that can be a problem with some devices. In general, it's not too bad. But the issue with a lot of those devices is that while they can regulate voltage, so a generator, depending on what type and what brand and how old, the voltage might go up and down a bit, whereas the voltage you get from the grid is very stable. So they will be able to regulate voltage, such as this old one here. So if you put in 230 volts, 250 volts, it will be able to regulate that. That's okay. What it can't regulate is the frequency. And the frequency is really, really important because you can't pass dirty power with a wrong frequency through to a lot of devices. And the UPSs will just stop providing or charging. They'll stop taking energy from the grid or the generator, right? And what happens is that the battery is the only thing that's running, so you run out of power. And that's what happened with me a lot of the time. Because the UPS couldn't charge, it would only last a few minutes, and then it would run out, 20 minutes or something, when the generator was running. And then we get to these, and that was one of my criteria. I'll get to my criteria in just a second. These are what's called double online conversion topology. So they're always online, as in the battery is always running. You're always powering devices from the battery. That's what the online means, whereas most of the other UPSs are offline. They don't actually power with the battery because the power goes straight through. So these are online. And the double conversion is that the AC power that comes from the grid goes into these, gets converted by DC, charges the battery, and then the battery discharges in AC again, which means you get this perfect voltage and perfect frequency, very pure and pure sine wave power. Now, if that's a lot of information to take in, I get it. It took me a while to get to this point of actually understanding what I needed, right? So, and speaking of what I needed, I had quite a few criteria to these devices before I bought them. First of all, I wanted a rack mount. This is a rack mount, and I needed a desk mount. This is a desk mount. That wasn't too hard to figure out because the rack mount needs to go in this server rack behind me at the bottom, and the desk mount needs to go next to the other server cabinet where the rack just doesn't fit one of these. I wanted to have enough battery capacity to run for an hour or more when the power goes out, right? Whether I got that right or not, we'll see. But yeah, I'll get to calculations in just a second. But that was one of the criteria, so I've based it on that. I needed them to be able to run off a generator, obviously. So I needed that online double conversion topology that I mentioned just before. So both of these have that. That was really, really important. That's crucial because sometimes we have power outages that are 8-10 hours. Yes, I live in the middle of nowhere. It happens. I wanted it to be remote monitor capable. So neither of these have a network card yet, but I'll talk more about that at the end of the video and how that might work. But I wanted that to be an option. So both of these will support that. And I want a pure sine wave output. So I needed proper clean power to come out of them. So both of these support all of these features. And they also have a lot more, I think, because there's things on the back of these that I don't know yet what they do. But that's where you come in, because if you enjoy this kind of content and you want to see me do more, you can support the channel. For instance, by commenting, letting me know what I don't know or other ways of doing things. I do enjoy the comment sections on my videos. I reply to pretty much all comments. If you want to subscribe to the video, now is a great time to do that too. This year I'm going for 50,000 subscribers. 50,000! And currently we are almost at 31,000 time of recording, so I think we can do it. There's a bit of work to do, but with your help, we might be able to get there. And if you really want to show your support for the channel, consider becoming a member. I do all sorts of behind the scenes content and small videos about things, other things I do on the farm and all sorts of things for members only, so you can do that too. But enough of that. Let's actually have a look at how we calculate runtime for these. When you look up the specs for these UPS devices, a lot of the time you'll see a VA number and a watt number or W number. So, and it's a bit confusing because they're sold as both, like you might see either number. So the way I understand what this is, and again, correct me if I'm wrong, the VA is short for volt amps. This is the theoretical max power that a device has. So for example, this device, the numbers on this, as it says on the side here, is 2000 VA, but 1800 watts. And if you know about electricity, volt times amps equal watts, right? So the volt amps should be equal to the watts, you'd think. But the way that apparently it works for UPS is that the VA number is the theoretical, as I said, and the watts rather, is the actual output of the batteries that you can expect. So I don't know why we don't just get the watts, but again, let me know in the comments. I don't quite understand that part of it. So this one is 1800 watts. This one is, as it says on top here as well, 1350 watts. So the reason I went for these sizes is that I did a simple calculation. So I roughly estimated what the wattage is, the watt usage is for this rack. And it sits somewhere between 300 and 400 watts. So in an hour, it'll use 300 watt hours, right? Maybe 400, it depends a bit. It's a little bit tricky to figure out how much they use unless you put a measuring thing on there, which I haven't done. I should have done that. Anyway, here we are. But there's a rough idea based on specs of the devices, how much they might use. So if it uses, say, 400 watts, this has 1800 watts of battery capacity, Well, I should get about 4 hours, right? 4 times 400 is 1600, give or take. That's what I'm expecting, maybe about 4 hours. Now, I have been wrong on this before, very wrong, and I'm not sure what I did wrong, but I think that calculation makes sense. So that's what I'm hoping, about 4 hours for this, maybe a bit more. The other cabinet uses maybe about 200 watts because it runs the UDM SE, it has my Pro 24 switch, and it has Starlink as well. So all those three combined with all the different PoE devices that I attached is about 200 watts. This is 1350, so I should get maybe 5 or 6 hours. So we're running at about 4 to 6 hours, I'm hoping, for these two devices. But of course, it all comes down to practical testing, which we'll get to. Maybe not having an actual power outage. I don't know if I can do that in this video, but we can probably sort of guesstimate based on the displays on the front as well, how much it says there is left to go, like how much time there is on the batteries. So that's how you calculate what size UPS you need. Not terribly difficult, I think, but yeah, that number of VA and W, that throws me off a bit. Okay, enough talk for now. I think we should install these, plug everything in, and see what happens. Just before we put it in the rack, let me just try and explain all these bits, because a lot of this is new to me as well. I'm gonna start at the top. So here we have a throwback to 1992. There's a serial port, an RS-232 I believe it's called. That's for connecting to a computer via serial. Yeah, you do get a sense that this is very backwards compatible, or UPS technology has not advanced much in the last 20 years. Not sure which one it is, or both. There's also USB, which is the same feature. You can connect either to a computer, but not both. Then there is the relay output, and that is, you can have a device that is connected to the UPS so that you can send a signal that something, that this is going to battery mode, and you can then pick that up and you can do other things, I assume. I'm not entirely sure what I would use it for, but it seems useful. And then you have the EPO, or the emergency power off. So this is a switch where if something goes horribly wrong, things on fire, I don't know, something like that, you can switch the UPS off like nothing, like completely off, like that, in an instant. Then there's a fan, only one fan, so it doesn't apparently get too hot. Anyway, down here we have the bat detector. So that is if you connect a second UPS battery, or third or fourth, I guess you could expand these. You connect that somehow to let it know, I guess, that there is a spare battery or expansion battery on it. This is again a throwback to so your fax doesn't die. Or your phone line. This is like a surge protector type thing, and you can have your phone running through here, in and out. So these are not RJ45. This is the expansion for connecting another battery, so plus minus, and it says here 48 volt, DC 40 amps is, I'm guessing, CyberPower sells those batteries as well, so you could add another one. Maybe I have to do that in the future, who knows. This is where you'll attach that, for example, a network card. It's like an expansion slot. So again, I'll talk more about network cards at the end of the video because I have an idea with that. These, I'm not sure. I couldn't quite figure out what these were. They seem like they're, for another model. If you buy the bigger, more fancier one, they'll have stuff there. And then we have 4 power outs. Obviously, this is why we have a UPS. 4 are critical load and 4 are non-critical load. And I'm guessing, I haven't figured this out yet, that you can configure when the non-critical loads power off, like percentage left on battery or minutes or something like that, I would imagine. But yeah, so there's 8 outputs here in general, 4 critical, 4 non-critical. And then down here, how we power the UPS from the grid, and a breaker switch, safety switch. So that's it. Now let's put it inside the cabinet and fire it up. So both UPSs are installed. Here's the smaller one, so I can turn this on the display. It is on, everything's running. And you can go through all of the different measure or diagnostics that come out of it. Now, one thing that I have noticed here is that the runtime has come here up as 35 minutes. I'll talk more about that when we go up to the office for the big UPS, because it's something I don't understand. Anyway, this is running just fine. You can see everything that comes out. It puts out 230 volts exactly. That's kind of the idea with these topology, where it goes through the battery. So it's always clean and lovely energy. But a whole bunch of stats here. You can also go into the settings. I won't do that in this video, but I'll talk more about that when we go up to the big UPS. And here is the rack mount UPS. Working well. Yeah, I plugged it right in. You can see I still got a bit of cable management to do at the back there. But it's, well, by the way, actually, I forgot to mention that on the back, there's also a ground connector or earth wire. Do hook that up. I have connected it to the cabinet, which is grounded as well. So don't forget that. These, yeah, if you have a surge and there's no ground, terrible things can happen. But it's in. This is a more advanced beast than the other one. Obviously, it's a lot bigger. For example, and I'm not going to go through that in this video, the manual says there are 32 UPS items that can be set up by the user. 32 settings on it. And that's obviously with a combination of the buttons there. And some examples is that I can change the output voltage, 208 volt, 220, 230, 240. Default is 230. You can change the bypass V window, which I don't know what is. You can put an eco mode. You can have an EBM number. I don't know what that is. Extended battery module. Oh, the number of extended battery modules. I just learned a thing. Generator mode, screensaver, clear event logs, reset load energy, battery tests, and date time, and a whole bunch of other stuff. So there's a lot of settings on it, and I'm probably not going to really use any of that just yet. I'm just going to use it as a UPS for now before I start delving into all that. And that brings us to, well, the elephant in my room. Let's just go here. As an example, it's using 280 watts, roughly. I suspected it was 400. I was way over, but that's fine. What was my calculation? 1800 watts divided by 280 watt hours would give me about 5 hours? Something like that? Yeah. If I go here and I go to the actual minutes of it, which is, here's the battery voltage, battery percentage is 100, right? It's fully charged. Battery time, 41 minutes. That's not 4 hours, 5 hours, whatever it was. And I don't understand why. I just don't get why it's 40 minutes. I'm not mathing, obviously, accurately. I just don't understand where. I thought it was pretty simple. So I did what any good tech citizen should do and asked ChatGPT, why am I so much off? And apparently, according to ChatGPT, which always gives you a positive answer, has something to do with the efficiency rate. Yeah, I know, that's 0.9. That's why you have 2000 VA and 1800 watts. We talked about that. Then it said, the voltage curve for lead acid batteries go sharper down, so you don't get the full voltage all the time. Okay, but that much less. There was something else about the efficiency of actually passing it through the battery means I lose some watts, so it's more like 320 watts instead of 280. I'm like, okay, fine. That still doesn't explain it. So I'm looking at you. Could you please explain, if you know, why I'm getting 41 minutes and not 4 hours or something? Like, what am I doing, not doing wrong, but what am I misunderstanding? What don't I get? Because that's a lot of batteries. There's 25 kilos of batteries or whatever it is. And I thought it would be running for longer. Now, 40 minutes, 50 minutes, totally acceptable for me. I can absolutely, that's enough time for me to go and start the generator and get it all up and running, etc. So that's not a huge issue. I just don't understand the calculation. Yeah, so please help. And then there is the last thing, which a few of you, when I posted a photo of them initially when I received them, you said, ooh, why'd you go lead acid and not lithium iron phosphate? Which is a good question. Main reason is cost. Simple as that. These two were $1,500 Australian, or just over. I can't even get one of these with the same capacity for $1,500 with lithium ion. They're much more expensive. Now, you could argue, and I know you have in the comments, yeah, but they last longer. So the expense, you know, is spread out over more years. Yeah, that's great. I still have to come up with the money up front, right? And the budget for this was about $1,500, so this is why I went with these. Also why I went with CyberPower. I've used them before, they worked well. I chose the wrong UPSs, but they work well. So there are many brands of UPSs. I'd love to try some of the other brands if someone wants to send me one. Hint, hint. But so far I'm pretty happy with this. I mean, it's a UPS. What apart from battery quality, what can go wrong? And CyberPower is a pretty reputable brand. It's probably one of the lower cost brands, I think, just from what I can see online. But I can't really complain. So that's where I'm at. Now, I did mention this a few times in the video. You can expand these with network modules. You absolutely can. That's going to be a future video. I am going to do that. I am going to put network modules in the two UPSs, and I am going to try and get it into Home Assistant. I know you can, so that's a future video. Stay tuned. Each of the network modules is about $300, so you know the budget just got to be there before I upgrade to that. But that's coming, so I can get everything into my home automation as well and get alerts, etc. That would be amazing. But other than that, again, if you enjoy the content, if you enjoy me spending hours on the floor here for you, please consider subscribing. If you want to support the channel more, you can check out the merch. I do a whole bunch of different designs that you can get on anything you want. Mugs, pens, slippers, towels, t-shirts, or you can become a member. Members on my channel get a few behind the scenes videos, well, quite a lot actually. I did one for this video on all the mess I had and how I had a particular challenge with this cabinet because of the rear door, but that's all in that video. Like the video, just press the thumbs up. It helps the algorithm and gets more eyes on all of this. So thank you so much for watching. I hope this was useful. It's been quite the journey for me, a lot of research, but it will continue, and I hope you'll join me. So see you next time.